This is for class 12. Class 12 for preparation for any competitive examination. Competitive examination. That is, I am dealing with your first two chapters of class 12, that is electrostatic and electrostatic force. This is electrostatic force and potential. See, some of the important things, how would you think about it? Suppose suppose let us take an example. You have read about potential. So when you have read about potential, you have also read that how to suppose this is a system, it is given in your book. Suppose this distance is A, B and C, and here, so you have to arrange three charges in this manner. If you have to arrange three charges, let the charges be Q1, Q2 and Q3. If you have to arrange these three charges in this manner, so what will be your total work done? What will be your total work done? What will be your total work done? This is in your book. So in this arrangement, what you have learned, that is, let us bring any of these charge. Let us bring the charge Q1 to point A1. Because there is no field, so your work done here, work done is 0. Work done is 0. Now suppose I bring this charge Q2 to here, then what will be the work done? So because Q1 has already existed here, so the potential due to Q1 at B. So let this be distance, say R1, this is R2 and this is R3. Let this be the distance. So you have read about it, that the potential at B because of Q1, this will be potential at B because of Q1, K Q1 by R1. This will be your potential. Now when you bring this charge Q2, then the work done will be, your work done will be K Q1 into Q2 by R1. So this is your work done. But here you see the important thing here is that when you bring Q2, it has been not explained in your book from where you are bringing Q2. This has not been told you. Just you have to bring Q2 from where, it is not explained about it. So from this, some basic concept arises. That suppose here there are 3 points A, B, C. There are 3 points, and everywhere the potential is same. Here VA potential, here VC potential, everywhere the potential is same. Now, if we have to bring a charge, say Q from here to here, what will be your work done if you are bringing this charge? So here I have already told you that when I brought this charge Q2, from where I have brought it, it is not explained in your textbook. That means that point is not considered while calculation work done. Only the potential here, this is VA, so the work done will be QVA. This is the work done. This is the work done at E. Similarly, when I bring the charge Q to C, here the work done will be, QVC. Again, when I bring this charge Q to point B, so here your work done will be at B, will be QVB. So here you see that since the potential are same, So at this 3 points the potential are same. So here your work done A will be equal to work done B will be equal to work done C. See, this is a concept. This is a question arises from here. So automatically this a question arises from here. So the main point I want to tell you, when you are studying this, here you see that when you brought the charge Q2, from where you brought the charge, that is not explained in it. That means that factor is not at all considered. Only the potential at B is considered, and when you bring the charge Q2 at B, your work done becomes 3. So from this concept, a question arises. So let us see this A, B, and C. They are the 3 points, and all these potentials are same. Your potential VA is equal to VB is equal to PC. Now when you bring this charge Q to here, your work done will be this. When you bring this charge Q to this, your work done will be this. And when you bring this charge to B, your work done will be this. Since your potential are same, your work done is equal. So how the questions are being formed. Now again, let us take another example. Suppose here is your charge, say some charge say Q, and here is your some charge say minus Q. This is say A and this is B. So now you bring this charge Q from B to C. Now I bring this charge from B to C. This minus Q charge I bring it from here to here. So again you see that because of this your the potential here was K Q. Let this distance be. Let us take that it forms an equilateral triangle. Let this be equilateral triangle. So all this distance are the same. Now because of this potential here your because of this potential here because of this charge, the potential KQ by A, and the work done here will be work done that will be minus Q will be K minus Q by A. Now same, because of this here the potential will be KQ by A, and your work done bringing this charge from here to here, that is work done will be work done will be equal to K minus Q A meaning Q by A. So here again we see that because this another factor here, that means the work done will remain the same. When we bring from here to here, your work done will remain the same. The work done here, the work done here, and the work done here will remain the same, because again we see that the factor is we are bringing this Q to this point. This from where we have brought this has no matter. Only the matter is what is the potential at C. So here again you see that same works are being done. So such type of questions, basic questions arises from this simple theory, Again, one very important question arises from here. You see that when you are arranging this, first of all you brought the charge Q1, your A point, your work done is G. Now because of this here at point B, your potential is, because of Q1 your potential is K Q1, and let this distance be R1. So this is R1. Now when I brought this charge, let me bring the charge Q2. When I bring this charge Q2 to this point here, so your work done will be Q1 into Q2 by R1. This will be your work done. Now see an important question here. When I have brought this charge Q2 at point B, here we are calculating about this, the potential created by this, and the work done in bringing the charge Q2 to here. But we are not calculating the vice versa. That means when Q is brought here, then what will be the potential yet here? We are not calculating about it. We are not calculating about it. See the important point which I am telling you, that Q1, you brought the charge Q1 at A, so your work done is 0. Now, because of this, the potential here is this one. So at this point, when you brought the charge Q2 here what is the work done is here. But when the Q2 has come here, we do not go vice versa, what will be the potential at this, because in bringing the, suppose we are going to bring another charge Q3 here, then we speak about this potential due to Q1 and potential due to Q2. But we do not go the vice versa, what will be the potential here because of B. We do not go for the vice versa. This is the very important fact. So why I have told you this, now let me give you an example. Suppose this is a sphere. This is a sphere having a charge Q on the surface. Now there is another cell. This is another spherical cell. This is a sphere, and this is a spherical cell. So here this is uncharged. This is uncharged. This is uncharged. And the potential difference between this and this is V. Between these two surfaces, this solid surface and the cell surface, your potential difference is V. Now, at this moment, now if you bring a charge, another charge, say another charge here, then what will be the potential difference between these two surfaces? So again the same thing. When you bring this charge here, we do not do the reverse calculation. So here we do not go for the reverse calculation. So here the potential, even if you have brought this charge Q on this uncharged surface, your potential difference will remain the same. So such type of basic concept which comes from this simple theory. So again, let us move to another topic. That is, let us move to another topic. So another topic. Let there be a charge Q1 and Q2 which are separated by some distance A, and they are let to fall freely under gravity. They are let to fall freely under gravity. So now the question arises, what will be your maximum velocity? So again, in such type of questions, see, there are two charges Q1 and Q2. They are let to fall freely under gravity, and V is your V. We have to find the velocity. Final velocity. Now, how you are going to solve this question? So we will go for conservation of energy. Now we will go for conservation of energy. So, for what is the potential initial? So we have to calculate the potential initially. We will consider this as a system. So when we brought the charge Q1, your work done is 0. But due to Q1, the potential here is Q1 by A. Now when I bring this charge Q2 here, so here your work done will be K Q1 Q2 by A. This will be your potential work done. So this will be your work done. That means your total potential energy of the system. This will be the total potential energy of the system. So this potential energy, this work done has been converted into kinetic energy. So kinetic energy of this will be kinetic, that is half m, let the mass, both the mass be same, m v square and half m v square. So your total kinetic energy, kinetic energy will be equal to how much? This plus this, it will be mv square. So this will be a total kinetic. So if you now equate these two, that is K Q1 Q2 from conservation of energy, that will be mv square. So K Q1 Q2 by m A root over, this will be your final velocity. So here again I am telling you one thing, that is how to calculate this work done of this system, work done. So you consider this as a system, and again see the same technique which I told you about the system. This A, B, C, the total work done by the system. So you have to consider this as a system, and so this system, when it falls under gravity, the kinetic energy plus this and kinetic energy sum up, that will be the total kinetic energy. So from conservation of energy, this work done has been converted into the kinetic energy. So you have to solve these questions like this. Now again you see. About a capacitance, about the capacitance. Here you see about the capacitance. About the capacitance here. Capacitance. So here you know that capacitance, that is its formula is C is equal to Q by V. So Q by V. Now when I have inserted a dielectric here, when I have inserted a dielectric here, so here your capacitance will be C naught will be equal to Q V naught. Here you see. Now you know that C naught, now let us take this, initially let us take the C naught, V naught, and final this is V. So you know that C by C naught is equal to dielectric constant, you know about it. Now here again you place this value, that will be C Q by V by C naught Q by V naught is equal to K. So this will be V naught by V is equal to K. So here you see one thing, what do we get the result? That is V by V naught is equal to 1 by K. So V is equal to V naught by K. This is the result you are going to get. Why I have done this? Now, why I have done this? So here you see the potential difference when dielectric is placed. What happens? It is V naught by K. And here you see C by C naught, that is equal to C. Here C is equal to K into C naught. And in both the cases, you see that your charge P remains the same. In both the cases, you see that your charge remains the same. Now, suppose this is a capacitance fitted with a dielectric, and is connected to a cell. Suppose this is, we are connecting to a cell. Now, if we remove this dielectric, what will happen? If you remove this dielectric, then what will happen? So when you remove this dielectric, means when dielectric was fitted to you, your V, the potential difference was less than the initial potential difference. Your potential difference was less than the initial this potential was less than the initial potential difference. So when you remove this dielectric, that means when the dielectric was present, the potential difference was less than the original potential difference. Your potential difference here was less than the original potential difference. So when you remove this, that means you remove this, it will try to reach its original potential difference V0. It will try to reach the original potential difference V0. So since V0 is greater than, because V0 is greater than V, so what will happen? When you remove this dielectric, charge will start flowing through from the cell to the battery. Your charge will start flowing from the cell to the battery, from the cell to the capacitor. So see how questions are created and how your formulas, you must be very, very clear with the formulas. You must be very, very clear with the formulas. What is telling the formula? Here this formula, you see the charge remains the same even if you insert a capacitor. Only the capacitance increases, but your C potential difference decreases. So when you remove the capacitor, it will try to come to its original potential difference. So charge will start from the cell to the capacitor. So why I am telling you about this, all this, because see how questions are created for the competitive exam and how much you must go deep through each formulas, what they tell us, and what type of questions may be asked. So this is all about for today. Thank you.